All right, well, I'm glad there are 3 people who are taking their Super Bowl Sunday afternoon to be with us to talk about using Insightmaker to teach differential equations. I'm going to share my screen with just a few slides now. It'll be short on slides, and then we'll actually go in and look at some insights really soon. All right, so first thing, I'm just gonna hop in there and say, what are the parameters of the class that I'm teaching this, using this software in? So the prerequisite is Calculus 2, so it doesn't have a linear algebra or a multivariable calculus prereq. Most of the students are engineering students. The class that I teach is definitely modeling focused. It's something that we do a modeling scenario about once a week. I schedule my class in a computer lab once a week. The other 2 days are kind of develop material, and then we go work on modeling with the computer. So it's not a fully SIMIODE approach, but it's still definitely modeling focused. Most of the scenarios that we use for modeling, many of them are either SIMIODE, just from SIMIODE, or they're in the SIMIODE textbook. I also have just kind of a catalog of things that I've done over the years. All right, so the first thing I always do when I talk about using Insightmaker and teaching is kind of set up the straw man of, so that I can defend the way I teach my class. The kind of possible student outcomes out of the differential equations class. The first is a differential equation is something that you get some sort of thing that you call a solution to it based on some procedure according to how the differential equation looks. At the beginning of the semester, you do some integrals, and then you don't do any integrals anymore. And then and obviously I mean for this to be the bad version of teaching differential equations. The second version is to really think of a differential equation as a mathematical model where every part of the differential equation is meant to have some contextual meaning. And clearly, if you teach classes, you think, well, this is something that should be happening in an algebra course. It doesn't always. And I would assert that using this thing called Insightmaker is a good way of having students develop their differential equations literacy so that they really, when kind of at the end of the semester and you're eventually, yes, you want to be able to look at a differential equation and solve it. But reading that differential equation and seeing how different parts of it are going to affect the solution is something that you can really start to build practice with Insightmaker. Briefly, what is Insightmaker? It's systems dynamics software or stock flow modeling. These are things that aren't typically forward in the kind of normal ODEs class. Anything where you read literature in epidemiology, stock flow modeling is very standard in that space. An SIR model, you always have this diagram, and it's like, here's SIR, and you have these flows between them. Just to give us a little glossary of what are these things, when we talk about stocks in Insightmaker, stocks are roughly your dependent or state variables of your system. So it's the things that are changing with time that you're interested in modeling. Variables are parameters or other quantities. So if you think about, that constant in your differential equation, you would enter that as a variable. Links in the stock flow model are arrows between a stock. So a link is an arrow between a stock, flow, or variable that just allows you to use the source of that link in the formula for that the object to which the link points. It makes, it's a little bit of a mouthful, but it makes once you start working with it, it kind of makes sense. The thing that I didn't actually define in this is what a flow is. A flow is, so you have stocks, it's some sort of quantity. Your stock, we'll see one where the stock is velocity. There's a flow into velocity. The flow rate into velocity is just acceleration. And so when you say, here's the time derivative of a stock, you've got, it's the sum of all the inflows minus all the outflows. So if this is a standard thing, when you do those tank modeling problems, it's rate in minus rate out. And you just kind of say, hey, we can do this with anything. Just to give a little bit of an overview of other system dynamic software that's out there. This is my brief review of what is the functional state of other system dynamic software out there. Insightmaker is the one that I'm kind of pushing for today because I use it. It's easy to use. There's a pretty low overhead for the students, and it's free. There's this one called Stoke SD. It allows for some stochastic processes. It's downloadable locally. Making it run is always, how well maintained it is questionable. The kind of not free versions, if anybody's ever used Simulink is a variant of system dynamic software. It's got its pluses because it works with MATLAB. Unless you're teaching a course in Simulink, you could kind of get lost in the use of it versus just learning some differential equations. And then there's this last one called Stella. Stella is, it's stock flow modeling software. The free version is fairly limited, but it's another one that's out there that people use. I'm pretty sure these slides will be shared. All of these in the slides actually are links to where you need to go. So the rest of this talk, I'm actually just going to dive in and do some Insightmaker. This QR code actually takes you to a little brief pre-text book. I'm developing a bigger one on really robustly using Insightmaker in a DEs class. That's a work in progress right now. This is also posted on the abstract. And so the things that we're going to look at is just, okay, how does Insightmaker work on a really basic level? And then we'll look at, so if you're familiar with the SIMIODE textbook, the Hill-Keller sprint model is the first example in that textbook. So this is something that I would do the first week of class, and we can just see how it works. And we can see kind of the workflow of a modeling problem really presented graphically with Insightmaker. And then we'll also see some of the other functionality where you can, it has built-in functions. So there's the drug dosage model in SIMIODE, and I've got references, if you're not familiar with these, then I have the references are in that pre-text book. So I'm going to jump out of here real quick and share Uh, okay, so this is the kind of brief SIMIODE Expo free textbook that I've got here. And so this is just a brief, what is a stock or a flow? And we're gonna, all of these the tabs that I've got open, except for the SIMIODE Expo Zoom tab, are the Insightmaker models that we'll be looking at today. When we're looking at, so I'm just gonna briefly look at this little picture of a flow. In Insightmaker, this is what flows look like. The one with the little hollow arrow that's upstream of that flow. So that's where stuff is flowing from. And then the closed arrow is where stuff is flowing to. So whatever's on the closed arrow, this flow is flowing into that one and it's flowing out of the upstream stock. So that's how you can do the inflow minus outflow. And in the discussion after the talk, I can probably, just get into a little bit more of the details, how I've actually worked on parsing these things into, maybe it doesn't need to live on some website. So the first one I'm going to look, so if you click here, and again, this is so it's eamcalister.github.io SIMIODE Expo 24. All of these, if you click on the full screen insight, it'll take you to that insight. And so I'm just going to open up this thing that says the basic integrator. I'm going to zoom in on that because it's actually pretty small. It's big enough. So here are the basic components of an insight. So the G here is the stock. And I'm just saying big G is the antiderivative of little g. And I'm going to click on that inflow. And the inflow is cos of seconds. The G here has an initial value of 0. And then I can run simulate. And it gives me sine because sine is the antiderivative of cosine. This is the basic construction. This is how stock flow modeling works. I can change that formula to whatever I want. And in particular, what I can do, so I'm going to jump to the next one. So this is just a Malthusian growth model. So it's the basic population model. The thing about, so if I click on this flow rate, you'll see R times P, where R is this variable. So things in the elliptical pink boxes are variables. The things in the square blue boxes are stocks. And then we have flows. Just how this works, whatever that flow connects to, you can use in that formula. Implicitly, you can always use time in the formula. In this case, I'm just doing, P prime equals RP. The nice thing is that you have R as a little slider here, and you'll notice I have R in 1/weeks. Everything gets units. Well, everything can have units. You can leave your whole model dimensionless. One of the things that I do with my students is say, hey, you need to make sure everything has units, and Insightmaker will in fact do the verification that you have a dimensionally consistent model. We can run this simulation and we'll see some other ones. So there are a lot of pretty cool features in this. So it just ran a simulation. The little thing up there that says sliders linked. So if you're kind of used to using Desmos or something, which many of our students are, you get the kind of Desmos approach where if I move this slider now, it changes the simulation. If you use some fancier You know, you use a smaller time step on your numerical method, it's slower, etc. But you can do things like this. So this is just what are the basics, right? You can integrate by taking a stock and building a flow on it. You can use these parameters that have sliders attached. You can have you can make the initial value a parameter with a slider, because that's something that one is prone to do. So the first thing I'm gonna do, or now that, you know, if you have a question, please speak up and say, hey, I don't get how that's working. One of the things that I encourage anyone to do is make yourself an Insightmaker account and play with it. There a question? I see one person might be talking, but I don't hear. And I'm actually gonna make sure my chat is open. All right. So the next one is this Hill-Keller model, and it looks big right now. Okay, so another feature in Insightmaker is that there is storytelling available. I'm gonna say start the story. Okay, so we begin by creating the velocity stock, and this is a model where we are modeling the velocity of a sprinter, and we'll eventually get to the data that is in the SIMIODE textbook. So you create that stock. So I'm not logged into Insightmaker right now. So how a stock is what's called a primitive. Make the stock, and then you say, okay, what are the things that this stock depends on? You add a flow for the different things that it's dependent on. So you've got a propulsive force and a resistive force. Make a flow for each of those. And then you say, you know, somewhere in the background, you have to decide what the formula for the propulsive force is and what the formula for the resistive force is. The thing that I'm just gonna really point to right now is that these are two components of the right-hand side of that differential equation. And kind of the best, a good practice for the students is try to break up that right-hand side of the equation into pieces so that you see what each piece does. And so both of these I've made have units of acceleration. So I divided out by mass for the whole problem, essentially. So if I click on the formula, I'm not actually using k times mass times velocity, it's just velocity times k. And notice the flow rate doesn't have a negative on it. And that's because this is strictly an outflow. It is only allowed positive values. So this is an outflow from velocity, and we can, have we understand that that's what's happening. The P and the K are some parameters, and through the model, we're going to leave P as 11 and vary K. So, and step forward. This is one of the nice things that you can also do is that a velocity, the data that you have might be distance. Creating that first order system from a second order equation becomes an obvious thing to do, because you just create, we've got two stocks, that's a system of differential equations now instead of a second order equation. And now I'm gonna do the simulation and say, okay, we simulated. Do we get to 100 at the appropriate time, which is some 9.2 seconds or something, and we say no. And so that means the resistive force is not big enough. So K is too small. At this point, I would have students playing with K. One of the cool things that we can also do is display that as a table. And another thing that we can do is a step forward. We got the table. We can play with K. We've seen the slider linkage. The other thing that we can do is do optimization. So I've got this thing called the end error. It's the distance minus 100. And if I say so I've run this simulation under settings for, so 0.165 to 9.525 is the length of the world record 100 meters. If I click under tools and optimization, if I want to minimize that end error, that's going to minimize the difference between 100 and the distance that's been run after the world record time. And I can run that optimization and it does it, you know, an optimization thing and says, K is about 9.25 or 29. And you can even, so this is something where we're really getting at what's the workflow of one of these models. And then the other thing that you can do is, so another type of variable is what's called a converter, where you can put in a data set. And then I can take the mean squared error and optimize on that as well. So if I change this and say, I want to minimize the integral of that object, and there are some little issues about how that's working. I can run that model optimization as well. It takes a little longer, but again, here we get that.
Okay, I've got my mic off.
Just let me know.
Okay.
And I think someone was just talking and I didn't hear them. Sorry, are there questions out there? All right, so this is kind of what are you able to do in terms of that first, like what is the workflow of a model? And you can see the different components of that model. So there's also a harmonic oscillator model there. I'm gonna jump to this drug dosage model just to finish up with that. This is you've got an injection and a metabolism rate, a dose size, and an administration time. One of the things that I actually really like about this is that I can start talking about step functions in the context of this model. And so there is a built-in step function in Insightmaker, and then I can even start changing the time over which that administration happens. And this would be something that I do before we start talking about discontinuous forcing functions when we're studying Laplace transforms, where a student can really start to see what the delta function is going to do and how it's going to affect the solution to the differential equation without getting into a lot of the hangups about notation and the table of Laplace transforms, etc. All right, I'm going to stop sharing now because we're about out of time. I am going to be jumping over to the discussion room about this. Anybody who wants to know more, I've got a lot of use cases to discuss, and potential issues if you want to discuss those as well.